we've done this week on ionic bonding. The main focus were the two tasks that you've just completed. One was the cartoon and one was the bonding worksheet, so we're going to have a look through those. First thing to generally pick up, I'm really impressed with how people have persevered with this. It's been quite challenging to get your head around ionic bonding because it's quite an abstract concept, and it's the kind of thing that in a classroom normally there'd be lots of question and answer and we develop the ideas. But I'm really impressed with the way people have just pushed on and sent me messages and I've been able to respond and help you through this. So really, really pleased with how everyone's got on with this. First of all, the cartoon task. Some of you chose to do this. I was really impressed with how you got on with this. The idea was to try and show in a slightly different way what happens when a metal loses an electron and a non-metal gains an electron or more than one electron, leaving a positive ion and a negative ion, and those ions are then attracted together. Range of work here which was really impressive. I've just picked out a few of the examples I've got to try and fit them onto one sheet. One thing to really remember, and this often comes up in exam questions as well, is people talk about the electron going from one atom to the other atom, leaving a positive particle, a positive ion and a negative ion, but they forget to then say that positive ion is then attracted to the negative ion to form the compound. And that would then make sure that you get absolutely full marks in an exam question. So it's really good to see some of you taking the creative approach with that one. The second task, there were two sheets here. There was the support sheet, which gave you some of the structures to give you an idea of how you needed to go through it, and the extension sheet, which didn't give you much support at all, and really expected you to work out how many electrons were being lost or gained, but also how many different atoms/ions you needed to make a balanced compound. Again, really impressed with how people got on with this. What I've done is put specific comments on your work. So as you scroll through your work, you'll see there are comments. I've highlighted different areas and written comments on those, and then put a generalised comment as well. Also, lots of people got house points for this, so they will be going on to the system at the end of the week. So I'll be able to tot up this week's and last week's house points. So looking at this, again, some really good examples. A couple of things to really try and remember. So if we look at this example here, nice and clear, showing the electrons going from the metal to the non-metal, but what it's not showing are any brackets or the charge on the compound that's been formed. So that would be really important. Here, really nice, we've got a diagram showing the electrons going from one to the other. And we've got the charges being shown as well. But what's really important, again, is that those charges are in brackets around the ion that's been formed. And also, if we look at these two diagrams here, this is the finished diagram. This electron here should still be like that one there because it's come from the metal. Going through here, really nice clear example, and this is what we needed to be able to do. So no mistakes on here, really, really clear, just showing the outermost electrons, which is exactly what you need to do in an exam. Showing the electrons have left the calcium, one has gone to the chloride ion, the other one's gone to the chloride ion, leaving the calcium with a 2+ charge because it's lost 2 electrons. And each chloride ion has got a negative charge, and that really results in 2 negative charges which balance out the 2 positive charge. So that would be full marks in a GCSE exam question, and that's exactly what you need to be aiming for. Another example here, a hand-drawn one, showing the same kind of thing. So we've got aluminium, which did have 3 electrons on the outer shell. It's unstable, it needs to become stable, so it'll lose those 3 electrons, resulting in a 3+ charge. Fluorine needs 1 electron, but aluminium's giving away 3. So to take away those 3 electrons, we will need 3 fluorine atoms to take those electrons, 1 each, and turn into a fluoride ion. So here we can see when aluminium and fluorine form the compound aluminium fluoride, we have 3 fluoride ions for 1 aluminium ion. And again, that's where you need to be aiming for. In an exam, obviously you are not working in colour, so you would use the dot and cross technique. So rather than 2 different colours, you would use dot and cross, which is what was shown in the some of the other examples I've given you. So general comments to leave you with. As I said, really impressed with how everyone's got on, but a few things to pick up on. First of all, take real care with the neatness and precision of these diagrams. Some of you worked on paper and hand drew the diagrams and did them very, very neatly. Some of you rushed them a little bit. Now, that's where you're likely to lose marks, especially in an exam, because you might not draw the electrons very clearly. And always count that you have got full outer shells. So in your non-metal, you have got the 8 electrons in the outer shell. Going back to the point I made previously as well, always use dots and crosses to show the electrons and where they have come from. It doesn't matter which way around you do it, but stick to that rule. So if you've said the electrons in the metal are a cross and the electrons in the non-metal are a dot, stick with that. I showed you a previous example using colours, the same idea, make sure you stick with the same colours throughout. Once you've made the ion and the electrons have gone on to the new substance, make sure you put a bracket around the ion, like I showed you in the previous example, and don't forget to write the charge of the ion, so what charge that ion has now got, now it's lost or gained electrons. So, last 2 weeks, I'm really impressed with how everyone's got on. We've gone through covalent bonding, so I think the next topic that you'd be doing with me, working on chemistry, would be looking at covalent bonding, which is another type of bonding, a little bit different to ionic, but it would be the next step we take. I'm not setting you massive amounts of work to over half term, but Friday's lesson does have a task, and the deadline for that is going to be midway through half term. So you'll have a couple of days to get that done. And then I look forward to seeing you on my next block of chemistry teaching. Thank you very much.